welcome to today's session. Python is a powerful and beginner-friendly programming language, and today we are exploring some of its key building blocks that make coding dynamic and efficient. Whether you are automating tasks, making decisions in your program, or repeating actions smoothly, mastering today's concepts will level up your Python skills. Let's dive in and see how Python makes programming both simple and fun. Today we are diving into three essential building blocks of Python programming: operators, conditional statements, and loops. These concepts are the foundation of writing efficient and logical programs. Operators. Operators allows us to perform calculations, comparisons, and logical operations just like a calculator, but inside our code. Conditional statements help our programs make smart decisions based on given conditions, similar to how we decide what to wear based on the weather. Loops enable us automation by repeating tasks without manual effort, making our code more efficient and reducing repetitive work. By understanding these concepts, you will be able to write Python programs that can think, decide, and repeat actions intelligently. Let's explore them together and see how they work. We are starting with one of the most essential topics you will come across while writing code: operators in Python. So, what exactly are operators? In simple terms, operators are special symbols or keywords in Python that let you perform operations on variables and values. Think of them as tools that help your code do things like calculations, comparisons, logical decisions, and much more. To help you visualize it better, let's imagine a real-world scenario. Suppose you are cooking a dish. You have raw ingredients like vegetables, spices, and oil. But just having ingredients isn't enough. You need actions like chopping, mixing, heating, right? These actions are what bring your recipe to life. Similarly, in Python, your variables are like ingredients and operators are the actions that process them to produce results. Now here's something interesting. Operators are everywhere in your code, even in the most basic programs. Whether you are adding two numbers, checking if a user is above 18, combining multiple conditions, or even checking if a value exists in a list, you are using operators. And Python doesn't have just one or two operators. It has a variety of them, grouped based on the kind of work they do. For example, some operators help with arithmetic like adding or subtracting numbers. Some compare values, checking if one is greater than another. Some assign values to variables. Others deals with logical conditions, binary data, membership checks, and identity comparisons. As a beginner, understanding operators is crucial. Why? Because operators are the foundation for writing logic in your code. If you want your programs to make decisions, perform calculations, or analyze data, you will need to master operators. Don't worry, even the word operator might sound technical. Once you get the concept, it's actually very straightforward, and by the end of this series, you will be using them with confidence. In the upcoming slides, we will explore each type of operator in Python, one at a time, with clear explanations, real-life comparisons, and simple code visuals to help you fully grasp the idea. So get ready, because learning operators will unlock a whole new level of understanding in Python programming. Let's begin with the first type, arithmetic operators, in the next slide. Let's now dive into the first and most familiar type of operators, arithmetic operators. Just like we use arithmetic in our daily life to count money, calculate time, or measure ingredients, Python uses arithmetic operators to perform basic mathematical operations. These include plus for addition, minus for subtraction, asterisk for multiplication, slash for division, double slash for float division, modulus for modulus or remainder, double asterisk for exponentiation. Let's understand what each of these does. First, the addition operator. It simply adds two values. You can add numbers and even combine strings using this operator, like joining two words, but we will focus on numbers for now. Next is subtraction. It subtracts one value from another. Very straightforward. Then we have multiplication. This multiplies two numbers just like regular math. You will use this often in loops, calculations or scaling values. Now comes division. This gives you the result as a decimal even if both numbers are integers. For example, dividing 5 by 2 will give you 2.5. But what if you only want the whole number part of a division, ignoring the decimal? That's where float division comes in. It divides and truncates the decimal part, returning only the integer value. Then we have the modulus operator. This one gives you the remainder of a division. So if you divide 7 by 3, the remainder is 1. That's what modulus operator gives you. This operator is super helpful when you are checking for even or odd numbers or when creating patterns or loops. Finally, there is the exponentiation operator. This raises a number to the power of another. For example, 2 raised to the power 3 gives 8. It's like doing repeated multiplication in one go. Let me give you a fun real world analogy to help remember this. Imagine you are running a bakery. You add ingredients, that's plus. You subtract the cost of materials from your sales, that's minus. You multiply batches when you get more orders, that's multiplication. You divide a cake among customers, that's division. If you only care about how many full slices you can give, you would use, that is, float division. If there are leftover crumbs, that's your remainder. And if you are doubling or tripling recipes based on orders, that's exponentiation, growing exponentially. These arithmetic operators form the backbone of so many real-world Python programs, whether it's in building systems, calculators, data analysis, or even games. In the upcoming examples, we will explore how to use these operators in code and how they behave with different data types like integers and floats. But for now, just remember, arithmetic operators are your go-to tools for all basic mathematical operations in Python. In the next slide, we will move on to relational or comparison operators which help your program make decisions. Stay with me. Now that we have covered arithmetic operators, let's move on to the another super important category, relational operators, also known as comparison operators. These operators don't perform calculations. Instead, they compare two values and return either true or false based on the comparison. Let me list them for you. Equal to, not equal to, greater than, less than, greater than or equal to, less than or equal to. Let's just understand what they do. Equal to checks if two values are equal. For example, checking if your age is equal to 18. Not equal to checks if two values are not equal. This is used when you want to make sure two things are different. Greater than checks if one value is greater than another, useful for things like comparing scores or checking if a number is above a threshold. Less than checks if one value is less than another, like checking if someone's speed is below the speed limit. Greater than or equal to checks if a value is greater than or equal to another. For example, allowing users who are 18 or older to register. Less than or equal to checks if a value is less than or equal to another. Think about discounts for customers under 25 or checking for exam cutoffs. Let's take a real life analogy. Imagine you are entering a theme park. If your age is exactly 18, you get a discount. You get a student discount. That's equal to. If your age is not 18, no student discount. That's not equal. If you are over 60, you get a senior citizen ticket. That's greater than. If you are under 5, you enter free. That's less than. If you are 60 or older, you also qualify. That's greater than or equal to. If you are 12 or younger, you go to the kids zone. That's less than or equal to. You see, these comparisons help the system make decisions just like your Python programs do. Now here's the key point. Relational operators are mostly common used in decision making. They go hand in hand with if statements, loops and filters. Whenever your program needs to choose a path, it will compare values using these operators. For example, checking login credentials, validating age or inputs, comparing scores, prices or quantities, automating decisions in games or apps. And here's something interesting. Relational operators always return Boolean values, either true or false, so you can use them directly in conditions. So to summarize, relational or comparison operators help your Python program ask yes or no questions and make smart decisions. And once you master them, you can build logic into your code easily. Alright, now that we have covered arithmetic and comparison operators, let's move into a slightly more advanced but incredibly useful category, logical operators. These are the operators that help your Python program make decisions involving multiple conditions. There are only 3 logical operators in Python, but they are very powerful and or not. Let's understand each one clearly. AND operator. The AND operator returns true only if conditions are true. Think of it like this. You want to go out for your walk, but only if it's not raining and you have finished your homework. Both conditions must be true. Only then you can go out. In Python, that's how AND works. It checks both sides and gives true only if both conditions are satisfied. OR operator. This one is more flexible. The OR operator returns true if at least one of the conditions is true. Now let's say you want to watch a movie. You are okay with either going to the theater or watching it online. If either option is available, you are happy, so the result is true. That's exactly how Python's OR operator works. If even one condition is true, the entire result is true. NOT operator. This one flips the result. If a condition is true, using NOT makes it false and vice versa. It's like saying, I will eat outside only if I am not tired. So if you are tired, the condition fails. If you are not tired, it succeeds. In Python, NOT helps you reverse a condition, which can be super useful for validations or filtering logic. Now let's connect this to programming. Logical operators are most commonly used if statements, while loops, complex conditions where multiple rules apply. Here's a simple way to remember them. AND, both must be true, or either can be true. NOT, opposite of the condition. Let me give you a real life analogy that ties all 3 together. Imagine a school rule. You can enter the library only if you are wearing a uniform and have your ID card. That's and you can participate in a game if you are in class 10 or 12. That's all. You cannot go to the school trip if you haven't submitted the form. That's not. These are logical decisions and Python handles them exactly the same way using logical operators. So to summarize, logical operators help your Python code think smartly, combining multiple conditions, making decisions and controlling the flow of your program. And when you combine them with comparison operators, that's when you write truly powerful, dynamic and logic. Up next, we will look at another operators. That's one that help you efficiently. Let's continue. Welcome back. Now let's talk about a very simple yet essential category, assignment operators in Python. As the name suggests, assignment operators are used to assign values to variables. This is something you will do all the time while coding. So understanding these operators is really important. Let's start with the basic one. Single equal sign. This is the most common assignment operator. It assigns the value on the right hand side to the variable on the left hand side. For example, x equal to 10 means you are storing the value 10 in the variable x. Think of it like giving a label to a box. You write x on the box and put 10 inside. Now whenever you call x, you are referring to 10. But Python also gives us some shortcut assignment operators. These helps you update a variable's value more easily without writing repetitive code. Here are few of them. Add and assign, subtract and assign, multiply and assign, divide and assign, floor divide and assign, modulus and assign, exponent and assign. Let's go over what they do. Plus equal to adds the right hand value to the variable and assign it back. Example, x plus equal to is the same way as x equal to x plus 5. Minus me equal to means subtract and assign. So x minus equal to 2 becomes x equal to x minus 2. Similarly, asterisk equal to multiplies, divided by equals to divides, and so on. These operators are very helpful when updating values inside loops, game scores, counters, or when calculating running totals. Let's take a simple real life analogy. Imagine you are saving money in your piggy bank. If you put 10 rupees in today, you might write savings plus equal to 10. If you take out rupees 5, that's savings minus equal to 5. If you double your savings after a gift, that's savings asterisk equal to 2. These are all assignment operations combining math with value updating in one clean step. So to summarize, equal is used to store or assign a value. The rest like plus equal to, minus equal to, asterisk equal to, etc. are used to update that value quickly. They make your code shorter, neater, and more efficient. In the next slide, we will explore another operator which are bit more technical but very powerful when working with binary data. Let's continue. Now let's talk about something super intuitive, membership operators in Python. These are used to check if a value exists in a sequence like a string, list, tuple, or dictionary. Python gives us two keywords for this: in, not in. In operator, this checks if a value exists in a sequence. It returns true if the item is present. Example, if you write A in apple, Python will return true because A is indeed in apple. This operator is very useful when searching inside strings or checking if an item exists in a list before doing something with it. Not it operator. This does the opposite. If it checks if a value is not present in the sequence. It returns true if the item is missing. For example, x not in apple returns true because there is no x in that word. Real life analogy. Imagine you are checking if your name is on a guest list. If your name is there, in. If your name is not there, not in. So in programming, this helps you check presence or absence before taking action like verifying login usernames or checking such results. To summarize, membership operators are your quick tools to check if something exists inside something else. Up next, we will learn about identity operators used to compare memory locations of variables. Now let's move to a slightly different category. Identity operators. These are used to check whether two variables refer to the same object in memory, not just whether they have the same value, but whether they point to the exact same memory location. There are only two identity operators, is not. Is operator. This returns true if two variables point to the same object in memory. For example, if you are saying A equal to 1, 2, 3, and then say B equal to A, both A and B refer to the same list. So A is B will return true. Even though they look like two different names, they point to the same object. Is not operator. This returns true if the variable do not point to the same memory location, even if their content might look the same. So if you write A equal to 1, 2, 3 and B equal to 1, 2, 3, A is B will be false because they are two separate lists in memory. But A equal to B will still be true because their values are the same. This is the key difference. Equal to checks value equality, is checks object identity. Imagine you and your friend both have identical notebooks. The content inside is the same, but they are two separate books. Is will be false. Only if you are both holding the same notebook, same pages, same pen marks, would is return true. So to wrap up, identity operators help you check whether two variables are actually referring to the same object in memory, which can be really useful when working with large data structures or optimizing memory. And that brings us to the end of the different operator categories in Python. Alright, now we are stepping into a slightly more technical category of operators in Python, the bitwise operators. These operators allow you to work with the binary representation of numbers. Every number in Python is stored in memory as a series of zeros and ones, also known as bits. Bitwise operators perform operations bit by bit directly on these binary digits. This might sound complex, but it's actually a very powerful feature, especially useful when dealing with low-level logic, memory-efficient programs, or working close to the hardware. There are 6 main bitwise operators in Python. First, the bitwise AND operator, written as AND. It checks each bit in two numbers and returns a new value based on where both bits are on. Next is the bitwise OR operator. This operator compares bits and gives a result where either of the bits is on. Then we have the bitwise XOR operator. This one checks for difference. If the bits are different, the result bit is on. There is also the bitwise NOT operator. If it flips all the bits, turning ones to zeros and zeros to one. It's a unary operator, meaning it works on a single value. Now coming to left shift. This shifts all bits of a number to the left by a certain number of positions, filing in zeros from the right. And finally, right shift. This shifts bits to the right and drops the ones on the far right. All of these operators are based on how computers actually store and process data. They don't just compare numbers like relational operators. They go deeper, working at the binary level. So why are bitwise operators important? Even though you may not use them in day-to-day scripting, they are incredibly useful when working in areas like data compression, cryptography, or networking, optimizing performance in large-scale systems, doing binary calculations, or controlling hardware components. They are fast, efficient, and make your code very powerful when used in the right context. To wrap up, bitwise operators gives us a way to interact with the smallest units of data, the bits, giving us fine-grained control and high efficiency. Let's move on to the next topic. Let's begin an important and exciting part of programming, conditional statements. Conditional statements allow your program to make decisions, just like we make decisions in our daily life. For example, if it's raining, I will carry an umbrella. Programs also need to take decisions based on certain conditions. Conditional statements give programs this power. They let the computer choose different paths of execution based on whether the condition is true or false. In Python, the most commonly used conditional statements are if, the basic condition check, else, what to do when the condition is false, elif, short for else if, used when checking multiple conditions one after another. Together, these allow your program to decide what to do next rather than just following a straight sequence of instructions. Why is this important? Because without conditions, a program would always behave the same way, no matter what. But with conditional statements, your program becomes dynamic. It can respond differently to different inputs, situations, or data. Let's understand it in a real-world sense. Think of a traffic light system. If the light is red, you stop. Else if it's yellow, you slow down. Else if it's green, you go. That's exactly how conditional logic works in code, evaluating one situation at a time and acting accordingly. Conditional statements are the foundation of logic in any program. They are used everywhere, from simple apps to complex algorithms, for validating input, making choices, controlling flow, and reacting to user interaction. In short, they bring intelligence and flexibility to your code. In the next slides, we will go deeper into each type of conditional statement, understand their structure, and see how they work individually. Now let's explore the most basic and essential building block of decision making in Python, the if statement. The if statement allows a program to run a specific block of code only when a certain condition is true. You can think of it as a checkpoint or a question your program asks before taking action. When Python encounters an if statement, if it evaluates the given condition, which is usually an expression, that results in either true or false. If the condition is true, the code inside the if block runs. If it's false, that block is simply skipped. This helps us control what happens in the program and when. Let's imagine a simple real-life example to understand the idea better. Think of a classroom rule. If you score more than 90, you get a certificate. Here the condition is scoring more than 90. Only students who meet this condition get the certificate. Others simply move on, no action is taken. This is exactly how Python's if statement works. A key part of using if in Python is indentation. All the lines of code that should run when the condition is true must be indented properly under the if statement. This is how Python knows which block belongs to the condition. The if statement is often used when we want our code to check for one specific situation or rule. It's the simplest form of decision making but extremely powerful when used correctly. You can use it for checking user input, validating data, controlling the flow of a program based on real-life conditions. To summarize, the if statement helps your program make decisions. It executes a block of code only if a specific condition is true. It's the starting point for making your programs interactive, responsive, and intelligent. In the next slide, we will learn what happens when the condition is not true and how we can handle that. We have understand the if statement. Let's talk about its natural companion, the if-else statement. An if-else statement gives your program two possible paths to follow. One path runs if the condition is true, the other runs if the condition is false. So instead of just checking something and doing nothing if it's false, the program now knows what to do in both cases. Think of it like this. If it rains, carry an umbrella, else wear sunglasses. Either way, an action is taken based on whether the condition is true or not. This is useful when we want to handle both the outcomes out of a decision. For example, when a user enters correct or incorrect information, a score is above or below the passing mark, a task is completed or not. Just like the if block, the code under both if and else must be properly indented in Python, so the interpreter knows what belongs to each part. To sum it up, if checks a condition, else handles the opposite case. Together, they make your program more complete and responsive to different situations. In the next slide, we will look at case where we have multiple conditions to check. Now, let's talk about situations where you have more than two possibilities to choose from. That's where the ELIF ladder comes in. ELIF stands for else if. It lets you check multiple conditions one after another in a clean and structured way. Here's how it works. Python starts by checking the first if condition. If it's true, that block runs and the rest are skipped. If not, it checks the next ELIF condition. This continues until a true condition is found. If none of the conditions are true, the final else block runs. You can think of the ELIF ladder as a chain of decisions. For example, if the score is above 90, grade is A. Else if it's above 80, grade is B. Else if it's above 70, grade is C. Else grade is F. Each condition is checked in order and only one block will run. The ELIF ladder helps keep your code organized and readable, especially when you are checking more than two outcomes. Without it, you would have to nest multiple if-else statements, which can get messy quickly. To summarize, use if for the first condition, use one or more ELIF blocks for additional checks, use else to handle anything that doesn't match. This structure is called an if-ELIF-else ladder, and it's a powerful tool to manage decision making in your programs. Let's now move on to the another topic. Now that we have covered basic if, if-else and ELIF, let's look at a slightly more advanced concept, the nested if. A nested if is simply an if statement inside another if block. It allows your program to make a decision only if a previous condition is already true. In other words, it's like asking a second question only if the answer to the first one was yes. Think of it like this: if it's a holiday, if it's sunny, go for a picnic. Here, the second condition is only checked if the first one is true. Otherwise, the inner block is ignored. Nested if statements are helpful when your conditions are dependent on each other. They give your code more depth and allow you to handle complex decision making scenarios. But it's important to be careful with indentation. Since you are placing one if inside another, your code must be properly structured so that Python knows which block belongs where. To summarize, a nested if checks a condition inside another condition. It's useful when one condition is relevant only after another is true. It makes your logic more detailed and context aware. But remember, while nested if can be powerful, overusing them can make code harder to read. So use them only when needed. That wraps up our discussion on conditional statements. Now that we have learned how to make decisions using conditional statements, let's talk about something just as important: loops. Loops are used in programming when you want to repeat a block of code multiple times. Instead of writing the same code again and again, loops allows us to automate repetition, making our programs shorter, faster, and more efficient. Let's think of a real life example. Imagine you are told to clap your hands 10 times. You won't write clap 10 times, you will just repeat the action. That's exactly what a loop does in programming. It repeats code as long as certain condition is true. There are mainly two types of loops in Python. For loop, used when you know how many times you want to repeat something. While loop, used when you want to repeat something until a condition changes. Both are powerful tools and each work best in different situations. Loops are super useful when processing items in a list, automating tasks, running code until a certain result is achieved, repeating actions like sending messages, checking inputs, or doing calculations. To control how loops behave, Python also provides loop control statements like break, continue, and pass. This help you pass, skip, or manage the flow of a loop more flexibly. Thus, to summarize, loops let you repeat actions efficiently. They reduce code repetition and they are a key part of automation and logic flow in any program. Now let's explore each type of loop, starting with the for loop. Let's begin with the first type of loop, the for loop in Python. A for loop is used when we want to repeat a block of code a specific number of times. It's best when we already know how many times the loop should run, or when we want to go through each item in a sequence, like a list, a string, or a range of numbers. Think of a for loop like going through a list of tasks. You perform each task one by one in order until you reach the end. In Python, the for loop automatically picks each item from the sequence and runs the block of code for it. It handles the counting or iteration for us, so we don't need to manage that manually. The most common use for the for loop is with the range function, which gives us a series of numbers to loop through. For example, we might say for every number from 1 to 5, do this task. But again, no need to remember syntax right now. Just understand that the for loop is saying for each item in this group, do this something. This type of loop is especially useful for repeating tasks a fixed number of times, processing each element in a list or string, running code for every character, every number, or every file in a folder. To sum it up, the for loop is structured, predictable, and perfect for counted repetition. It's commonly used when working with collections or ranges, and it helps you avoid writing the same lines of code again and again. In the next slide, we will explore the while loop, which is more flexible and continuous looping as long as a condition stays true. Now that we have seen how the for loop works, when we know how many times to repeat, let's look at a different kind of loop, the while loop. A while loop is used when we want to repeat a block of code until a certain condition becomes false. In other words, it keeps running as long as the given condition is true. Think of it like this: while the water is boiling, keep the stove on. As soon as the water is done boiling, the action stops. This is how the while loop behaves in Python. It continuously checks the condition before each loop. If the condition is true, it runs the code. If not, it stops. The key difference between for and while is for is used when you know how many times to run. While is used when you don't know exactly how many times, but you know the condition under which it should keep going. The while loop is very useful when waiting for user input, monitoring changes in data, repeating something until a goal is reached, running infinite loops that break under specific conditions. But with great power comes responsibility. If the condition in a while loop never becomes false, the loop will keep running forever. That's called an infinite loop. And we usually want to avoid that unless we control it with a break statement. To sum it up, a while loop repeats code based on a condition. It's useful when the number of repetitions is not fixed, and it gives us flexibility in building dynamic real-time programs. Up next, we will learn how to control loops even more using statements like break, continue, and pass. Now, let's talk about the break statement, a powerful tool to control how loops work in Python. Sometimes we don't want a loop to run until its natural end. We may want to exit the loop early as soon as a certain condition is met. That's exactly what the break statement does. When Python encounters a break inside a loop, it immediately stops the loop and moves to the code after the loop. It doesn't matter whether you are using a for loop or a while loop. Break works the same way in both. Think of a break like pressing an emergency stop button, no matter what the loop was doing. It halts instantly and moves on. This is helpful when you are searching for something and want to stop once it's found. You are checking user input and want to exit on a specific keyword. You want to prevent the loop from going too far in certain cases. To summarize, break is used to exit a loop early. It saves times and processing by stopping when needed. It helps you make loops more flexible and responsive. In the next slide, we will see another control statement, the continue, which doesn't stop the loop but skips a specific round. After learning about the break statement, which completely exits a loop, now let's look at the continue statement, which behaves a bit differently. The continue statement is used to skip the current iteration of the loop and move to the next one. It doesn't stop the loop entirely like a break. Instead, it says skip this round and go to the next one. So the loop keeps running, but it ignores one specific case that we don't want to process. Let's say you are printing numbers from 1 to 10 but want to skip all even numbers. You can use continue to skip the code inside the loop only for even numbers and continue with the rest. This is useful when you want to skip unwanted data, avoid certain values or situations in a loop, make your loop more focused on specific cases. To summarize, continue is used to skip one iteration of a loop. It doesn't stop the loop, just moves to the next cycle. It helps to filter out cases you don't want to process. Next, we will wrap up loop control statements with quick look, which does nothing but still has a purpose. Now, let's explore an interesting and lesser known feature in Python, the else block with loops. Yes, in Python, you can actually add an else block after a for loop or a while loop. But what does it do? Here's how it works. The else block runs only if the loop completes normally. That means without being interrupted by a break statement. So if the loop goes through all its items or runs until the condition becomes false, the else block will execute. But if the loop is stopped early using a break, then the else block is skipped. You can think of it like this. If the loop finishes cleanly, else runs. If the loop is broken midway, else does not run. This is especially useful in search operations. For example, if you are searching for an item in a list and you find it, you use break. If the item isn't found at all, the loop finishes naturally and the else can show a message like not found. To summarize, loops can have an else block in Python. The else runs only if the loop was not broken. It's useful to perform a final action after looping, only if no interruption happened. This feature makes Python loops even more powerful and expressive. With that, you now have a solid understanding of how loops work in Python. Up next, we will dive into practical examples and small programs using these concepts. Loops are one of the most essential building blocks of programming. Once you get comfortable with loops, they will help you solve many complex problems more easily and efficiently. As you continue learning Python, try creating your own loops to automate tasks and explore different scenarios. The more you practice, the better you will get at using loops to make your program smarter and faster. Thank you for watching this tutorial on loops in Python. If you found this helpful, be sure to check out the next lessons where we will dive into another exciting topics like functions, object-oriented programming and more. Don't forget to like, subscribe and hit the notification bell so you never miss an update. See you in the next video and happy coding!